Okay, so let's look into how to do these type of differentiations. When we have y equals to some bracket, we have some function of x inside the bracket, and we have power n of the brackets, right? So let's say I have this function y equals to what we were doing earlier, y equals to 2 over 3x squared plus 1 raised to the power of 5. So we can write this as 2 times 3x plus 1 raised to the power of negative 5, right? Now the power is negative 5 and 2 is here. So the first thing which we have to do is we have to differentiate the bracket, right? So dy by dx becomes 2 times negative 5 comes down 3x, it's 3x squared plus 1. 3x squared plus 1, the whole thing raised to the power of negative 6. Now we have to multiply this with the differential of whatever was inside the bracket. So 3x squared plus 1 was inside the bracket. So the differential of 3x squared plus 1 is 6x. So we multiply this by 6x. Finally, if we combine all of these together, we get negative 60x divided by 3x squared plus 1 raised to the power of 6. So this is my final answer of differentiation. I hope you get this, right? So now let's do a few more questions. Let's do this question as well. It says the curve y equals to, let's just copy this first. It says the curve y equals to root ax plus b passes through these 2 points, this point, not these 2 points, this point, and has gradient 1 over 4. So now we know that the gradient is dy by dx, right? First, let's rearrange this. We can write this as y equals to root ax plus b as ax plus b raised to the power of half. And if we differentiate this, dy by dx becomes what? First, we differentiate the bracket. So we get half ax plus b raised to the power of negative half. Then we differentiate whatever is inside the bracket. So ax plus b. If we differentiate ax plus b, we get only a, right? I hope you get this. Now, if we just simplify this a bit, so this becomes a over 2 under root ax plus b, right? So this is dy by dx. Now the question is saying that the curve passes through this point and the gradient is 1 over 4 at this point. So the value of dy over dx at x is 1 over 4, right? Sorry, the value of x is 12. So dy over dx is equals to 1 by 4 when x equals to 12, right? So if I plug in the value of x and dy by dx in this equation, I get 1 over 4 equals to a over 2 times under root 12a plus b. Let's call this equation 1. From where are we going to get the equation number 2? We know that this curve contains this point, right? This curve passes through this point. So I can plug in the values or the coordinates of this point into the equation of the curve as well. So from this I can get 4 equals to under root 12a plus b. And let's call this equation 2. Now from this equation 2 we know that under root 12a plus b is equals to 4. If we substitute this value in equation 1, right? So this under root 12a plus b can be written as 4. So we will get 1 over 4 a over 2 times 4, right? So this would give me 1 over 4 equals to a over 8, right? So this would give me a equals to 8 by 4, which is 2, right? So the value of a is a equals to 2. Once we get the value of a, we can plug in the value of a in this equation. So 4 equals to under root 12 times 2 plus b, right? If you square both sides, 16 equals to 24 plus b, and this gives me b equals to minus 8. Right? So this is how we differentiate when we have a bracket and a power of the bracket. Right? So now you have to do exercise 7b. So yeah. इसके बाद what we have to do is equation of tangents and normal. वो भी आसान है. That is very easy. Once you know how to differentiate, after that things are very easy. Let's do this question. So for this you need to get some basic, you need to revise some basic things from coordinate geometry. For example, to find equation of line, the formula is y minus y1 equals to m x minus x1, right? So let's do this question. It says find the equation of tangent and normal to the curve this at x equals to 2, right? So when x equals to 2, what is the value of y? Y would be 2 times 2 squared plus 8 over 2 squared minus 9, right? So y would be 8 plus 2 minus 9. So this gives me y equals to 1. So the point at which we have to find the equation of tangent and equation of normal is 2 comma 1. Now we have to find the gradient of the tangent line and the gradient of the normal line. We have already studied this and we know that dy over dx is what? Dy over dx is, we when we started differentiation we talked about this, that dy over dx is the gradient of the curve, or in other words we also call it the gradient of tangent line to the curve, right? So now we have to find the gradient of the tangent. So this is very basic. We have y equals to, if we simplify this, y is equals to 2x squared plus 8x raised to the power of minus 2 minus 9, right? So if we take dy by dx, so dy by dx would be 2 to the 4 x raised to the power of 1 minus 16 x raised to the power of minus 3, right? So this is dy by dx. We have to find the value of dy by dx when x is equals to 2, right? So the gradient of tangent, m of tangent, is equals to dy by dx at x equals to 2, right? So let's put x equals to 2 in the equation of dy by dx. So when we put x equals to 2, dy by dx becomes 4 times 2 minus 16 times 2 raised to the power of minus 3, right? Which is equals to 4 to the 8 minus 16 over 2 raised to the power of 3, which becomes 8 minus 16 over 8, which becomes 6, right? So the gradient of the tangent line is 6, right? Okay. Now we know that normal line is perpendicular to tangent line. So if the gradient of tangent line is 6, and if we can recall from coordinate geometry that the gradient of perpendicular lines are negative reciprocal of one another. So the gradient of normal line would be negative reciprocal of 6. So negative and reciprocal is 1 over 6. Right? So negative reciprocal. So m of normal is 1 over 6. Now we have everything that we need to find the equation of line. We know that the gradient of tangent is 6, the gradient of normal is negative 1 by 6, and both the points passes through 2 comma 1, right? This is the point which we find earlier, 2 comma 1, right? So both lines are passing through 2 comma 1. The formula for equation of line is y minus y1 equals to m x minus x1. So to find tangent line, we can write y minus 1 equals to 6 x minus 2. If we simplify this, y equals to 6x minus 12 plus 1. So y equals to 6x minus 11. So this is equation of tangent line. Now for the normal line, we can write y minus y1 equals to m x minus x1. Everything we're going to do is same as we did in for tangent line, except for the gradient. The gradient is going to be negative 1 by 6. So y minus 1 equals to negative 1 by 6 x minus 2. So this becomes y equals to negative 1 by 6x plus 1 by 3 plus 1, right? So we have y equals to negative 1 by 6x. What is 1 by 3 plus 1? I guess it's 4 by 3. 4 by 3, right? So this is equation of normal. Equation of normal. This is equation of tangent, right? I hope you get this thing. Okay. Now what you have to do is you have to do this question number 1 of this exercise 7c. What you can do is you can pause this video right now and try to do these questions. So yeah, you have to find the equation of tangent to each curve at a given point. So now you can pause the video. Okay, so let's do part A. So we have y equals to x square minus 3x plus 2 at point 3 comma 2. So dy over dx would be 2x minus 3, and at x equals to 3, dy by dx would become 2 times 3 minus 3, which is 3, right? So now the equation would become y minus 2 equals to 3 times x minus 3, right? So this becomes y equals to 3x minus 9 plus 2 is minus 7. So this is equation of tangent. Let's do part C as well. C is y equals to x cube minus 5 over x, right? So if we simplify this, this becomes x square minus 5x raised to the power minus 1. dy over dx would be 2x plus 5x raised to the power of minus 2. And we have to find the tangent line at point negative 1 comma 6. So this means that at x equals to minus 1, dy by dx, or the gradient of the tangent line, is minus 2 plus 5 minus 1 raised to the power of minus 2. So this becomes minus 2 plus 5 over minus 1 raised to the power of 2, which becomes minus 2 plus 5, which is 3. So the gradient once again is 3, right? And the points are negative 1 comma 6. So y minus 6 equals to 3 x plus 1, right? So we get y equals to 3x plus 3 plus 6, which is plus 9. So this is the equation of the tangent line, right? So you have to do 7b and 7c. So yeah, we'll discuss further in next class. And please do this homework 7b and 7c, otherwise you'll forget everything. Okay, take care. Allah Hafiz.